Hello, welcome back. Today we are seeing the different kind of layers that we will find in a deep neural network. Firstly, we have the fully connected layer, then the convolutional layer and the pooling layer. The first one is used in every single application of artificial intelligence. The convolutional layer and the pooling layer are only applied on images and maybe music recognizer and specific functions, but I have only seen applications in images. So let's start. The fully connected layer. If you've seen neural network representations on the internet, you've seen this structure. It's the common way to represent a neural network and the easiest one. You can the operations that the mathematical operations that you need are really simple. You can describe it using the matrix operations. To get the output, you need to multiply the vector A by the matrix weight and you will get the output. Then you apply, once you have done the product, you sum the bias, a bias that is a scalar value, and you apply an activation function that we will later see the different kind of activation functions that are commonly used on neural networks. This is really easy. The first part is really easy. Now we are going to see the convolutional layer. This is a bit more complex and we need the Hadamard-Weiss product. We multiplied the first a minor matrix by the weight matrix and using the Hadamard product, and then we sum all the values and we get the output. There is a really useful paper where you can see the convolutional neural network operation. It explains really well how it works, the different parts, the strides, the padding. It is really useful, and if you want to see the mathematics that are behind the convolution operator, you will find this really useful. So now let's continue with the pooling layer. The pooling layer is simple as that. You get a minor matrix and you get the maximum of the numbers and you output here in one box. There are also a different kind of pooling layer that is called the average layer, where you make the average of the matrix of this minor matrix and you output in the next layer. This layer is usually used to reduce the size of the matrix. So now we can start coding the layer. We open Visual Studio, and the next thing we need is to yes, we have the layer file, so we can start. We need the vector here. I haven't done that before, but I'm going to define a dpdef called double scalar. Okay, I will explain now why I have defined this sorry. You can use I'm going to use scalar instead of double because in the whole project, because if you want to change the 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 variable of that you want to use, it will be really easy. If you want to use a float instead of double, you only have to change the config. Okay, that's all. Now we can include the config. Okay, the random number generator and the optimizer .8. Okay, that's all. And we now can create the class layer. Now I'm going to define the eigenmatrix dynamic and it will be called matrix. Oh, sorry. Oh, I forgot to include eigen core. Okay, now it will be correct. This form, this kind of eigenmatrix is a dynamic one, so you can change in runtime the size of the matrix. So it will be easy to us to implement it. Now we define the vector, a vector that is dynamic. Okay. Yeah, vector has sorry. The first thing we have is the type. We know that a scalar is double. Now we have in the rows and the columns that are dynamic, and in the vector we know that we have in the number of rows, if I remember well, the number of columns only we have one. So that's all. Now we define the input size of the layer and the output size. If we look here, if we focus on this layer, we have on input layer 3 and on the output layer 5. So we will store this value in these variables. Now we can define the constructor of the class and everything. To create the layer, we need the input size that we have just created and the output size variable, and we now can initiate that. Okay, that's all. we have now defined the constructor of our class. We also want this class is only going will be heritage by other class like the fully connected, the convolutional layer, and the pooling layer. So we our functions will be virtual. The structure of the class will be virtual. Now we can define the getter of the getter to that will return the insize, our variables, okay, and the getter of the out size. Okay. Now we will define a lot of virtual functions that you may not understand everything. We need to define a init function that will initialize the weights of the matrix. Scalar constant scalar sigma, and we also pass through it the random number generator to generate the same weights as you generate. So I think we get an error because we haven't defined yet the random generator class. So let's wait a second. Virtual void the feed forward that I'm going to call forward. We need to pass through it a matrix, a dynamic matrix that will be the prep layer output equals 0. Okay. Yes, we need to define the protected before. Now it will be covered. Okay. Virtual constant matrix outputs. Now we are defining the function that returns the output of the forward functions. And now we are going to define the back propagation. You may not know what is back propagation yet, but it consists on we need to update our weights in order to make our function fits the output. So it is a bit complex because we need to know a little bit about derivatives. Propagation. Back prop. We don't need large names. We need to pass through the prep data, prep layer output, constant matrix, and the next layer data. Okay, I think that's all, and we have just defined it. Okay, back prop. Oh, sorry, I forgot to set it. And now we can define another virtual function that will get the back propagation data. Back prop data const This means that we won't change the backpropagation data. We are only getting it to whatever we want. Yeah, that's all I think. We don't need more. We don't need nothing. Yes, I will do another virtual std vector scalar where we will get the parameters of the function. Okay, we are also be doing this function virtual void std set parameters, and in this function we will set the parameters. That's all. Virtual, and in this function we can get the derivative in a std vector. Derivatives. That's all. We now need to define the random generator function. I have the code before, and you can look into the code to see what I have done, but it creates a random number based on a seed, and it asserts it makes search to us that we will get the same random number. We have to wait a few seconds. So I'm going to compile it, and now we are going to, yes, succeed. We are going to create the new layer, the new files, the new layers, fully connected layer. Yep, that's all. Add new item, the convolutional layer, new item, and the pooling layer. Yeah, that's all. This will be really tedious. We have to include a few things before. Eigen and the core. As I have done before. Okay. Now we need to include the header files of everything that we are creating now. The config, the configuration, the random number generator, the layer, the fully connected, the layer, the convolutional layer. We can now include the pooling layer. Yeah, that's all. Yes, we haven't defined the rest of it. Now we can start creating the fully connected layer. We need to include vector. I'm going to use the exceptions to check if there have not been an error. Okay, except and config. We make sure that we have included the layer .h, and that's all. We can now define the fully connected class that will heritage from layer. That's all. Okay. Now we can define also. We are also going to define the convolution now that will heritage from layer and the pooling. We will dedicate a complete video to every single layer of this, to program it line by line, because it is a little bit complex. So I think that's all in this video. Thank you for watching it, and in the next one we will see the different activations function for the layers. So see you.